Hello everybody. It is time for us to take a look at the 1-5 worksheet answer key. It occurred to me just recently that the previous answer key videos were all filmed in portrait mode because I am an idiot. So we're going to work these into landscape mode so that they actually show up better on video players. Hopefully this is a helpful change. We'll see. I don't know. So we'll start here with number 11. This has a lot of writing on this particular worksheet because it's a lot of conditionals and talking about why things are true and why things are false. So for this one, why is the following condition logically true? And logically does a lot of work in this sentence. If 20 is a multiple of 3, then 101 is a perfect square. Right, that's weird. We know 101 is not a perfect square because we know 100 is a perfect square. And we also know 20 is not a multiple of 3. That is the reason why this is logically true. Because if the hypothesis is false and the conclusion is also false, then based on the truth tables, it is logically true. So it's true because when the hypothesis is false, the conditional statement itself is true no matter what. The conditional itself is true no matter what, right? So if the hypothesis is false and the conclusion is true, then that conditional is true. If the hypothesis is false and the conclusion is false, then that conditional is logically true. The only time that a conditional can be logically false is if the hypothesis is true and the conclusion is false, and that is not the case in number 11. Number 14 says, write a true biconditional about angle bisectors. Biconditional is going to be a statement that includes if and only if. So we have this angle bisector right here, and if we want to talk about something that's true both forward and backwards, I've got to think about what angle bisectors do. And I say, well, angle bisectors divide an angle into two congruent angles. So I can say any given ray, right? Any given ray is going to be an angle bisector if and only if it divides the angle into two congruent angles. So a ray is an angle bisector if and only if. Remember, that's the statement we need in there in order for this to be a biconditional. If and only if it divides the angle into two congruent angles. And now you see we could read that both forwards and backwards, right? If we have a ray and it divides an angle into two congruent angles, then we know we have an angle bisector. If we have a ray that is an angle bisector, we know that it divides the angle into two congruent angles. So that biconditional there is true. Number 16, if a biconditional is true, what are the truth values of the hypothesis and the conclusion of the conditional? So there are actually two cases where this would be possible, right? In order for the biconditional to be true, it has to be able to be read both forwards and backwards. So the hypothesis and the conclusion have to have the same truth value. So if the hypothesis and the conclusion are both true, then that would be a true biconditional, and that would be the truth values. But it's also possible for the hypothesis and conclusion to both be false. because that would make a logically true statement when read both forward and backwards. So when we're asked what must be true about the truth values of the hypothesis and the conclusion, they must be the same. They must be the same. And I can go ahead here and say either true, true, or false, false. Okay? Because in either of those cases, the conditional will be true when read both ways. So in either case, the conditional will be logically true when read either way. Okay. Number 17, Emma found a counterexample to a given conditional. What are the truth values of the hypothesis and the conclusion? Well, the only way that the person could find a counterexample is if that conditional was false. Only false conditionals have counterexamples, and the only way for a conditional to be false is if we have a true hypothesis leading to a false conclusion. So if there's a counterexample, means the conditional is not true, and the only way that happens, the only way that happens is if the hypothesis is true, but the conclusion is false. All right, let's go on to the other side. So find the truth value of each conditional and explain your reasoning or show a counterexample. So number 22, if a pair of lines is parallel, then they do not intersect. We know this to be true because we know that the definition of parallel lines includes the fact that they don't intersect. So we can say this is true, and we can use the definition to explain. We can say parallel lines do not, I know that's two words, intersect by definition. We are allowed to use definition as a reason in geometry. We can say we know the definition of this thing, so we know that by definition this is something that doesn't intersect. Number 23, if the product of two numbers is positive, then the numbers are both positive. So this says if we multiply two numbers and the answer is positive, then we know that those two numbers must both be positive. So we could try to find a counterexample, or we could say that this is true and explain why. In this case, I know of a time where I can multiply two numbers and get a positive answer, right? If I can take a number times another number and give me a positive answer, I could say, right, that -3 times -5 is equal to positive 15, or really any negative times negative gives me positive. This disproves. This is a counterexample because we've got two numbers multiplied together that give us a positive answer, but both the numbers are not positive. So this is false. Number 24, write the negation of the hypothesis and the negation of the conclusion for the conditional. if the sum of the interior angle measures of a polygon is 180, then the polygon is a triangle. So there's two easy parts to this. First, we're going to write the negation, remember that's the symbol, of the hypothesis. So the negation of the hypothesis would just be using the word not in the hypothesis, writing if the sum of the interior angle measures of a polygon is not 180. So I'm going to make this bigger for ease of writing. If the sum of interior angle measures in a triangle is not 180, right? That is just the negation of the hypothesis. We also want to write the negation of the conclusion. So then the negation of the conclusion would be, then the polygon is not a triangle. We're just making it the opposite. So we'll say the polygon is not a triangle. Okay? Down here, we want to write conditionals and determine each truth value for the conditional. So we have a conditional statement. We're going to write the converse, and then we're going to write the contrapositive. So if an angle measures 100, then it is obtuse. The converse switches the hypothesis and conclusion. We can make it grammatically correct. We can say if an angle is obtuse, then it measures 100. And we say, well, is that true or false? I know some obtuse angles that don't measure 100, right? Obtuse angles are anything from 90 to 180. So false. That is a false statement. Then we can write the contrapositive of the original statement, which means we are switching the hypothesis and the conclusion, and we are negating both of them. So we'll start with the conclusion but negated. So we can say if an angle is not obtuse, then we'll do the negation of the hypothesis. Then it does not measure 100. And of course, those contrapositive truth values can be kind of difficult just to like read and parse through the sentence with all these negations. Remember that the truth value of the original statement and the truth value of the contrapositive are always going to be the same. So since that original statement is true, then the contrapositive has a truth value of true as well. Let's keep going. We got to write the inverse of that statement that we just wrote up above. So remember, the inverse is we're not going to switch the hypothesis and conclusion, but we are going to negate the hypothesis and conclusion. So if an angle does not measure 100, then it is not obtuse, right? And always the inverse and the converse will have the same truth value. So since the converse is false, the inverse is also false. Down here, we want to take this this biconditional, and we want to write both conditionals that we could write from the biconditional. So we'll take the hypothesis as the first part and the conclusion as the second part. Then we can also switch it around and we can say, what if the end of this is the hypothesis and the beginning is the conclusion? So one way we could write this is if a month has exactly 28 days, if a month has exactly 28 days, then it is February. Took me a long time to learn how to spell the word February. And then the other way we could write this is with the hypothesis and the conclusion switched, since it's a biconditional. So if it is February, and I'm trying to think of a way to write this grammatically correctly. If it is February, hold on. February, then the month has exactly 28 days. All right, we're getting through this. We're almost done, folks. Number 35, we have the hours for an art museum. And we want to write a conditional to describe the hours of the museum on Mondays, right? So if it is Monday, this is easy. If it is Monday, the museum is closed. So if it is Monday, then the museum is closed. All right. Down here, is this conditional a true biconditional? So could I take my statement in letter A and switch it around? If I say, if the museum is closed, then it is Monday. Is that true? That's not true, right? What if I go to the museum at midnight? The museum is gonna be closed, right? And it might not be Monday. So it is not a true biconditional. Not a true biconditional. And explain. So we could say maybe because the museum is also closed at night. Because the museum is also closed at night. Except for apparently on Sundays when the museum opens at midnight, which I think is probably a typo. That should definitely say 12 p.m. But what do I know? Maybe it's a midnight museum. Who has any idea? Number 36, consider the conditional P then Q, if P then Q, where P is true and Q is false. Copy and complete the table to show the truth value of each statement. So if the hypothesis is true and the conclusion is false, then that means the conditional is false, of course. If the conditional is false, its contrapositive is also false because those have the same truth value. And if we think about the other two, the converse of this statement would give us a false value leading to a true value, right? If we switch those around. If we have a false value leading to a true value, that is logically true. I know it seems weird, but it's logically true. And then, of course, the inverse is going to be the same truth value as the converse, so the inverse is also going to be true. And then finally, number 37, which represents the contrapositive of if P, then Q. Of course, we know the contrapositive is going to switch the hypothesis and conclusion and negate both of them. So it's going to be if not Q, then not P, and D is your answer. All right, and there you go. Hopefully this has helped you out. And if you have any questions, of course, make sure to ask in class. Thank you so much and have a wonderful day.